How's it going? Today we're going to look at special right triangles. And yesterday we did Pythagorean theorem, works on right triangles. And there's a couple of triangles that are special that pop up in a lot of places, and so we spend a little extra time on those. All right, here are the two that we're going to deal with today. If you have a square, let's say, occurs a lot of the time, and you draw this diagonal in here, it cuts it into two congruent triangles. But since this is a right triangle, right here, because it's a square, and these two sides are the same because it's a square, well, this ends up always being the same value. And in class I went through where it came from, but we're just going to cut to the chase here. If you have a square and you drop this diagonal, this is what we call a 45, 45, 90 triangle. Because when you draw that diagonal, one of the properties of a square is the diagonals will bisect this angle. So that 90 turns into a 45. And that one turns into a 45, and you got your 90. So this special right triangle is called a 45, 45, 90. Pretty fancy name. All right, now, it won't always be the square. Sometimes you'll just have the 45, 45, 90. It doesn't have to have the full square in there, but that's one of the places that you see it. And what will be the rule? Here's the rule. Here's what you've been waiting for. The rule is that this hypotenuse of the right triangle is always going to be whatever that side length is, that x, and if you multiply it by the square root of 2. So if these two sides of your square, or the sides of the triangle, are 7, then this will always be 7 root 2. If these are 10, this is 10 times root 2. If this is 9, then this is 9 times root 2. Okay, so if I know this leg right here, I can immediately just multiply by root 2 and I'll have the hypotenuse. And what also works then is if you already know the hypotenuse, you can divide by that root 2 to get rid of it, and then you would have the leg measurement. So multiply to go to the longer one, divide to go to the shorter one. Okay, the other special right triangle that we have comes from an equilateral triangle. And in an equilateral triangle, all the sides are going to be the same, and this whole side here would be the same. If you drop the altitude in an equilateral triangle, we talked about all those special segments, a median, an angle bisector, an altitude, all these things. Well, what's special in an equilateral triangle is that that segment is the exact same. This altitude that creates this right angle is also an angle bisector. It is also a median, so it hits the middle down here. So you can see I've already marked it as being this leg here, sorry. If this, well, let's just say this is 2x, then this is 2x, this is 2x. And if I drop this down here, this is only half of it, so I called it x. And it's a right triangle. And it's an angle bisector. So remember that in an equilateral triangle, this angle is 60, 60, and this was 60 until I dropped that, and that's an angle bisector, so now it's a 30. So the name of this triangle is, and of course we're only looking then at this triangle, the right triangle. I'm talking about this one right here. That is what we would call a 30, 60, 90 triangle. Okay, those are the angle measurements. Okay, doke. Now, not only do we know these two sides, again, and this all comes from the Pythagorean theorem. If you were to do this with the Pythagorean theorem, what you would find is that this leg here is always going to be half of your hypotenuse. Your hypotenuse is 2x. This is called your short leg. It's x. And this is your long leg, and it will always be your short leg times the square root of 3. So right here, I'm going to write this long leg is going to be x times the square root of 3. All right, so what that would mean is that if this short leg is 5, then the hypotenuse will be 10. And if the short leg is 5, the long leg would be 5 times root 3. All right, if this short leg, let's say, is 8, then this would have to be 16. The short leg was 8, this would have to be 8 times root 3. Right? Now that's everything kind of is based off the short leg, but I can get to that short leg. Like what if you already knew that this was 50? Well, if this hypotenuse is 50, then this short leg would have to be half of it. So this would be 25. And if this was 25, then this would have to be 25 times root 3. Happens every time. So let's practice that a little bit. I've got a slide here that shows you those relationships. And again, let me say this. If you're trying to go to the longer leg, and remember the hypotenuse is always the longest. So if I'm trying to go there, I'm going to multiply. So in the 45, 45, 90, I multiply by root 2. If I have the hypotenuse and I'm trying to go back to this leg, since I'm going smaller, I would divide by root 2. In the 30, 60, 90, everything revolves around the short leg. So you're always trying to get to the short leg, because from there you can double it to get your hypotenuse, or from there you can multiply by root 3 to get the long leg. Okay? If you're trying to go backwards, if you're trying to go smaller, then right here, if I want to go to just the short leg, I'd have to divide by that 2. Hypotenuse to short leg, I'd divide by 2. If I had the long leg, I would divide by root 3, and it would take me to the short leg. All right, so let's do it. In this example right here, they've given us the hypotenuse. Oh, it's 3 times the square root of 2. I want to go to the smaller leg, so I'm going to have to divide. And you're going to have to always be looking back at that previous slide so you remember that in the 45, 45, 90, that's the one that has the root 2 in it. So you are going to have to divide by root 2. Well, I'm not going to really show this every time, but this is pretty basic. If you have a 3 root 2 and you divide by root 2, those are going to cancel. You're just back to 3. So in the 45, 45, 90, the 2 legs are exactly the same, because remember it comes from the square. So those are both 3's. All right, let's look at this 45, 45, 90. This one's different because they've given you the short leg, or the leg. They didn't give us the hypotenuse. We just have this leg measurement. Okay, so I know that the other leg is exactly the same. So I can write that. That's the easy one. Now, I've got to take that and multiply it by root 2, because I'm going bigger now. I'm trying to get to the hypotenuse. I'm going to multiply by root 2. So I end up, it just happens to be that it's already a root 2. That's okay. Take the root 2 that's there, and to go bigger, I'm going to multiply by another root 2, which we have learned when you multiply identical radicals, you're just going to get that 2. So my hypotenuse ends up being 2. All right, so if you're going smaller, you divide by root 2. Going bigger, you multiply by root 2. There's 2 more. Let's try these. All right, the leg is 6, so this leg is 6. Those match. And then I have to take that and I have to multiply that by root 2. So legs are 6, multiply by root 2 to get to the hypotenuse, so it's going to be a 6 times root 2. Nothing fancy to do with that, that's just your answer. Take the leg times root 2. All right, on this next example, okay, I'm back to them already giving me the hypotenuse, so now I'm trying to go smaller, trying to go to those legs. So I have to divide by root 2. This one doesn't divide quite as beautifully. If I divide by root 2, oh, this is why we did the radicals a while back, because of this right here, these special right triangles. So this is where we have to rationalize that denominator. Remember doing root 2 over root 2? So that's going to become 10 root 2 over 2, and then we're able to reduce. That worked out great. Now I have a 5 root 2, and that right there is going to be my leg measurement. But because both of those legs are the same, it's also that leg measurement. Okay, I'm going to say it one more time. If you're going from the leg to the longer hypotenuse, you're going to multiply by root 2. If you're going from the hypotenuse to the leg, you're going to have to divide by root 2. And it might work out nice, or you might have some radical practice to be working on. All right, I'm moving on. I'm going to the 30, 60, 90 triangles. Now these are different. There's a little bit more involved because there's 2 things that you have to keep track of. You have the leg, the short leg. That's your X. Let's just look at this first example. The short leg. This is your X. Okay, from that previous slide over there where you had that was like outlined. You're in the border. It says remember this. Your short leg is just the 3. The hypotenuse is always double that. So what do you think this should equal? 6. That's right, 6. Okay, so we have that side. Now we also have to find the long leg. And if you peek back at remember this slide, if you have your short leg, to get to your long leg, you have to multiply by root 3. So I'm going to take 3 times root 3. And that will get me the long leg. It works great if you know the short leg. That's the easiest route. But this next one, it's not too bad. They did not give me the short leg, but they did give me this hypotenuse here. The hypotenuse is 10. But remember, that's always going to be double your short leg. So how long is the short leg? 5. I'd have to divide by 2. Now once you do the short leg, you take it back and multiply to get it back to the long leg. You're going to multiply by root 3 for the long leg. Again, remember this slide handy so you can see those relationships as we do this. All right, let's try this one. Getting a little fancier, you can see right here that they gave me the long leg. That's usually the worst situation when they give you the long leg. Okay, and as ugly as that is, it's actually going to work out pretty decent. Because if you look at remember this slide, the long leg is the one that has the root 3 on it. So if I want to go smaller, which I always want to get back to the short leg, I have to divide. And what do you have to divide by? Root 3. And this is going to conveniently divide nicely because 6/3 can reduce to 2 over 1. And a 1 we just ignore. This is going to end up a 2, and then that root 2 is still going to stay there. Now what we just found here is the short leg. We worked our way to the short leg. Now, to go from short leg to hypotenuse, that's a different relationship. I am going bigger, so I'm going to multiply. I have to multiply by, if you look back, to get from short leg to hypotenuse, you have to double it. So I'm taking a 2 root 2 times a 2. So you can multiply like parts, so these 2's get to multiply. The radical 2 stays put. So this is the hypotenuse. A little bit more work on the 30, 60, 90s. Last one here that I'm going to go through with you. All right. This time, oh, they did it again. They gave us the long leg. And it looks nicer, except it's not going to be, because remember the long leg's supposed to have the root 3, so we're going to end up dividing by root 3. This is not going to divide nicely. It's okay. We're going to power through the radicals. The long leg needs to be divided by root 3. And to get to the short leg, you're going to the short leg. So that's going to be a 4 root 3 over 3. And that one doesn't even reduce. That right there is the short leg. Ugly as it might be, we're going with it. All right, now I have to also find the hypotenuse. The hypotenuse, I go from the short leg to the hypotenuse, so I'm going bigger, going to have to multiply. I'm going to take my 4 root 3 over 3, and to get to the hypotenuse, I have to double it. So I think of it as like a 2 over 1. All right, I multiply the things that I can. That's going to be an 8 root 3 over 3, and once again, it is not going to reduce for me. So that's just what I have to write, and that is the hypotenuse right there. All right, so now what we did in class is we had a worksheet of just a bunch of 45, 45, 90s and 30, 60, 90s. Front page was 45, 45, 90s, back was 30, 60, 90. I partnered them up and had them practice. You should probably do that. Before I keep moving on, that's really what you need to do, is you just need to do a bunch of them until you start remembering those relationships. You can find that worksheet on our website. Now for the video, I'm going to keep on moving, but you really do need to practice that worksheet. All right, so I was going to throw in a couple of examples where you would see these special right triangles. And so on this first one, it says a high school softball diamond is a square. They call it a diamond, but it really is just a square because it's just right angles at all of your bases. So it looks like this. Okay, here's your catcher. Is that backwards? I don't know which way the plate. I think the plate faces the other way. Okay, and then this is second base. And there's your first base, and here's your third base. And the question says, the distance from base to base is 60. Got it. That's 60, that's 60. It's 60 all the way around. To the nearest foot, how far does the catcher throw the ball from home plate to second base? So they're throwing somebody out. Okay, I've got myself a 45, 45, 90 triangle here. That's it. There, you got your 90. Split it with this throw. All right, let's find this. That's the hypotenuse. Well, we just learned to get from the leg to the hypotenuse. This is in the 45, 45, 90. Peek back. Maybe you did the practice worksheet. Maybe you know. I'm stalling for you. It's 60 root 2. Now, the problem, though, is that that's a nice exact answer, but for this to make sense to anybody else, we're going to kind of want to have that rounded off. So we're going to type in the calculator 60 times the square root of 2. All right, and I have 84.85, but it says to round off to the nearest foot, so I'll do an approximation 85 feet for the catcher to throw somebody out that's stealing second. All right, next. The 4 blades of a helicopter meet at right angles and are all the same length. Okay, they're all the same length. Okay, so you got to have this. I'm just going to, like a bird's eye view of this helicopter. I have a blade that goes this. There's just 4 of them. So it looks like this. And they're all the same length. And they're all at right angles. So that would make sense. You want them evenly spaced. The distance between the tips of 2 adjacent blades, so that's from here to here, is 36 feet. How long is each blade? Okay, well that goes back to this right here. How long is the blade? Well, that blade is the same length as this blade, and I have a 90. This makes it another 45, 45, 90. Oh, I didn't say this earlier, but a 45, 45, 90 is really just what we call an isosceles right triangle. It'll have 2 sides the same, and it's going to have a right triangle, or a right angle. All right. In a 45, 45, 90, up here on our softball problem, we had to multiply by root 2. Since I have the hypotenuse, I'm going to divide by root 2. And then I'm going to rationalize. So that's going to be 36 root 2 over 2, which reduces beautifully to 18 root 2. The question is, how long is each blade? I have 18 root 2, but then it says come back and round to the nearest tenth of a foot. So I'll type that in the calculator. I'm going to do 18 times the square root of 2. And I have 25.5 is what I'd have to the nearest tenth. And then we would label that feet. All right, let's try this one. It says an escalator lifts people to the second floor of a building. And that second floor is 25 feet above the first floor. Got it. The escalator rises at a 30-degree angle. To the nearest foot, how far does a person travel from the bottom to the top of the escalator? Okay, ultimately you're looking for the yellow part here, the how far are you traveling on that. Now, the way they've drawn this, you've got this right angle going, you've got a 30, that's going to force this to be a 60 up here. We have a 30, 69. And what they've given us is conveniently the short leg. They gave us the 25. At the 25, the short leg, I want to know the hypotenuse. Peek back. What do you got to do to the short leg to get to the hypotenuse? You got to double it. It's times 2. So that's going to be, x is going to equal 50. And that's measured in feet also. That's how far you'd go up the escalator. All right, I got one more. Okay, kind of similar. This one's a conveyor belt. All the information is in the picture there. But this one's it's a little bit more in depth because it says, let's go ahead and read it here. A farmer's conveyor belt carries bales of hay from the ground to the barn loft. The conveyor belt moves at 100 feet per minute. We're going to need that information here. It's how fast that those bales are moving. How many seconds does it take for a bale of hay to go from the ground to the barn loft. All right, so they kind of walk us through. It says, which part of the right triangle does the conveyor belt represent? Well, that should be the hypotenuse. This is your hypotenuse of your 30, 60, 90 triangle. Now, it says you know the speed. Yep, I boxed that in. What other information do you need to find how long? Well, I need to know how far. Distance equals rate times time. Okay, that's ultimately what you've got. Distance equals rate times time. So let's try that. Distance equals rate times time. The distance, well, we've got to find that. That's our 30, 60, 90 job. And then this is the same thing as the escalator. If the height here is 12, the hypotenuse is twice that. So the distance is 24 feet. The rate is 100 feet per minute. I'm looking for the time. Divide by 100. And what does it say? They're just saying kind of how long. Let me divide that up, and we'll get a decimal for it, I guess. Okay, why am I doing that? Divided by 100 is 0.24. You knew that, right? Just move your decimal place back. All right, sorry. Okay, and this would be measured in minutes because your speed was given in minutes. 0.24 minutes. Now that's hard to understand what that means, so we would likely convert that into seconds. So if I want to go from minutes to seconds, I just take it times 60, and I get 14.4 seconds. That'd be another way to write that. I'll just do a little times 60 right there so you remember what you did. Okay, so I'm going to go with 14.4 seconds is how long it takes to get that bale up there. All right, that's all I've got for you. Your homework is on Math Excel, but also the worksheet. All right, good luck.